Hello. I want to tell you about your major Unit 3 individual presentation. Now, the start of the presentation needs success rate, and you're going to calculate your own success rate for some activity that you're going to decide on and let me know about what you want to do. Some examples are on this paper. You could do a sporting activity of some sort, and you could do some guessing games or something that has at least a 10% probability of success or likelihood of success. I'm going to do a little activity to show you what your project could be. So my activity, I'm going to change it very slightly from what yours is. You will do 50 tries, 50 trials. Do your activity 50 times. So I'm going to do just 20 today, so you will need to do 50 for yours. Now, I have to decide, here's my experiment, and I have this tub of items, and I want to know, I'm going to define success, let's call it success if I draw a blue item from the tub. So I'm going to draw 20 times, and each time I'm going to decide if it was a success or a failure. And success, again, for my activity, I just now decided we'll be drawing a blue item from the tub. So you'll determine what success for your own activity, and you'll then do your activity 50 times and record how many successes you had out of the 50 times. So here I go on my experiment. Closing my eyes. And, oh, first I drew a blue right away. Try again. There's a red. I'm going to put it in my failures column. And there's another red. I have 3 so far. There's 4. Oh, a blue. Another non-blue, so I'll put it in that same column. It's a failure. And here's my other one. It's another non-blue. I'm going to do a few, be really fast. Okay, those are fails, fails. Oh, I have a success in here. Some more failures. Let's count. Where am I? I can see you don't have my whole thing zoom out a little bit. All right, maybe not. So I have 2, slide my box over, how about that? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 2, 4, 6, 8, 10. Okay, so I have 14, so that means I need 6 more, so I'm going to grab 6 more. 1, 2, 3, 4, 5, 6. There's the rest of them. I have a blue. Okay, so there's my experiment. I'm done with that tub. And now I want to calculate my success rate. So I'm looking, I have 1, 2, 3, 4 successes out of 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 out of 20 draws. 4 success out of 20 draws or experiments. So if I look at my calculator, I want to just divide there, and I want to do 4 divided by 20, and I get 0.2. So I have a 0.2 probability of success for this experiment as I've designed it. Okay, you choose your own activity that you want to do. It cannot be the same thing that I just did. And then you will determine what means success for you, and then you'll do your experiment 50 times, count up how many successes, and figure out your success rate. I have a 2.2 probability of success or a 20% likelihood of drawing blue. Okay, now with that, the next thing that you need to do, let's go back to our instructions sheet. Calculate your success rate. We just did that. And now we need to look at what's the probability that you will have 12 successes out of 14 trials. And I'm going to modify that slightly. It says to use the binomial probability formula here, and we definitely want to do that. But if we have less than or equal a 30% success rate, which we actually did, we had a 20% success rate. If you have that small of a success rate, then instead of 12 successes, I want you to find the probability of exactly four successes out of 14 trials. Okay, now we're done with our data collection and our analysis of it. We just used that to come up with likelihood of success for this problem. So now we're just thinking about the problem in terms of if we were to do it 14 times, what is the probability that 12 of those times, if you had a success rate that was higher than 30%, or 4 of those times, what is the probability that exactly 4 of those times you had a success? Okay, so what we're going to do then is since I have 20% likelihood of success, my problem is now I want to know probability for 4 out of 14 trials. For success in 4 out of 14 trials. Okay, so I'm going to get rid of my little counters here since my experiment is completed, and now I'm going to do some calculating. So I want that formula. Okay, and remember the x, we have a few variables. Okay, n, that was the number of trials, and x, that was the number of successes, and the p was a probability of success, and q is the probability of failure. Now we know what all these values are because we know n, the number of trials, is from our question, so it's going to be 14. And the x, because we had a low likelihood of success, we're using the 4. And if you have greater than 30% success, then remember you'll use 12 in your experiment for your probability calculation. And then our probability of success, this comes from our experiment, and that we had 20%, and we'll have to convert that to a decimal, and that would mean our probability of failure would be 100 minus 20, or 80%, and so we'd use 0.8 for this one and 0.2 for that one. Okay, so we have all our values set up. Then we'll just plug them in. So the probability of exactly 4 successes is going to be 14, choose 4, and then my p is 0.2, and my x is 4, my q is 0.8, and my n minus x will be 14 minus 4, or 10. Now I just have to plug all those in on my calculator. See if we can show enough of that so you can see it. And I'll do 14, turn it on first. 14, and remember on this calculator you use the PRB button. And I move over to N choose R equals, so I have 14 choose 4, put in the 4 and the enter, and it says 1001. And then I'll do 0.2 to the 4th. There's my to the button, the 4th. So multiply by 0.0016. And then I'll do 0.8 to the 10th. That's my last piece, and probably a long decimal because I have a high exponent. 0.1073, I'm just going to write dot, dot, dot. And then take that, leave it on your calculator, and I'm going to multiply by the other piece. So times 0.0016 times 1001 equals 0.17197, and I want to round to the 10th, or the, I'm sorry, to the, I think it's 100,000, so tenths, hundredths, thousandths, 10,000ths. I want to round to the 10,000th place, or 4 decimal places. So it's going to be 0.1720. So then I want to write that out. I want to write out both my problem and my solution. So my problem I will write out as, I can turn that just a little bit. Okay, so my problem is Joan, that's me, Joan has a 20% success rate at choosing a blue marker from a tub of markers. What is the probability that she will choose 4 blue markers in 14, I think I need the word exactly here, in 14 attempts. Okay, so here's how I wrote out the problem. Joan has a 20% success rate at choosing a blue marker from a tub of markers. Do you see how I talked about my success rate from my experiment? And I talked about what it is that I was doing exactly so somebody else could duplicate it. What is the probability that she will choose exactly 4 blue markers in 14 attempts? So that's a statement of the problem that I did. And then I have my work up here that I could come back to, but I don't need to show that right now. And then I can phrase my answer. So my answer would be Joan has a probability of 0.1720 of choosing exactly 4 blue markers from a tub of markers in 14 attempts. Okay, so now I've phrased my solution Joan has a probability of 0.1720. Remember, probabilities are expressed as decimals. Of choosing exactly 4 blue markers from a tub of markers in 14 attempts. So 4 out of 14, that's what I came up with, my 0.1720. Now, the last thing that you need to know, let's come back to this and see how much of this we've talked about. You decide on an activity that has a definite success and fail, and then you talk to me about it. Make sure that I okay it before you get going on your data collection. And then you do the activity 50 times, and you record your successes, calculate your success rate. I showed you that. And then calculate the probability. You have one of 2 options that you're going to do. The first one is if your success rate that you found in number 3 comes out to greater than 30, then you will calculate the probability of 12 successes out of 14 trials. And if you're like me, where you came out with a probability less than 30%, you will calculate the probability of 4 out of 14 trials for successes in 4 out of 14 trials. Remember, for this one, you will use the binomial probability distribution formula. And then make a presentation about your experiment. So you're going to need to record yourself talking about it, explain your activity. So what did you decide to do? Report the number of successes you had doing the activity, and you can put in a short video of yourself doing the activity for extra points. Show your success rate calculation. So show how you figured out, in my case, the 20% success rate. Show that. Show how you calculated the probability that you'll have 12, and it could be that you did 4 out of 14. So you're going to show your work. That would be this work right here with your formula and what values you plugged in, all the way down to what your probability of success is. And then write your experiment as a problem that other people could work. That would be this part right here. So I wrote my experiment as a problem someone else could work, and that was number 5 here. And then number 6, write your answer out. So write an answer to it as a complete sentence, and that would be this part right here. That's my answer. And then make sure you pay attention to grammar and sentence structure. If you're using PowerPoint, it has a spell checker and a grammar checker, and I encourage you to use it, including on your titles, because I notice a lot of you are messing up on those. So if you're having any trouble with that, with any pieces of that, remember, I'll have my regular office hours this week. Please attend. You can just drop in for a few minutes, ask me your question, get it answered, and off you go. Or if you can't make my office hours, you can just email me. Remember, please get your topic, your data collection approved by me, either by email or Google Hangouts, before you do your data collection. Thank you.